Let's start with attention deficit hyperactivity disorder, a condition that affects many people, making focus, tricky, and energy levels unpredictable. What if I told you that underlying all this is a web of tiny molecules and cellular processes working behind the scenes? That's right, our brain's activity is deeply rooted in metabolism, process by which our cells produce energy and turn nutrients into useful compounds. One key player is the mitochondrial metabolism. Think of mitochondria as the power plants of our cells. They turn food into energy. Within this process, we encounter molecules like citrate, aconitate, and isocitrate, parts of the citric acid cycle or Krebs cycle, an essential pathway that keeps our energy factories humming. Imagine citrate as a currency in this cycle, shuttling through different stations, helping produce the energy our brain needs to stay alert. Scientists often study fibroblasts, skin cells that are easy to collect, to understand what's happening inside our bodies. Even in these simple cells, researchers look at plasma metabolites, small molecular floating in our blood like lactate, alanine, and pyruvate. These are like messengers or fuel indicators telling us how our metabolism is functioning. For example, elevated lactate levels might suggest that cells are working overtime or not getting enough oxygen, while alanine or pyruvate are closely tied to how our body manages sugar and energy. Interestingly, some metabolites such as oleamide and phenylethylamine also pop up in brain chemistry discussions. Oleamide, for example, is a fatty acid amide that can promote sleep, while phenylethylamine is a stimulant linked to mood and alertness. Certain regions of the brain, like dopaminergic neurons in the nigrostriatal system, are crucial for movement and reward. These neurons produce dopamine, a neurotransmitter that makes us feel good and motivates us. But maintaining dopamine levels involves complex metabolism, including enzymes like monoamine oxidase B, which breaks down excess dopamine and other monoamides. Diving deeper into the chemistry, fatty acids like oleic acid, arachidonic acid, and myristic acid are vital components of cell membranes and signaling molecules. GABAergic transmission is our brain's primary inhibitory system, like a brake pedal that keeps things from spiraling out of control. All this metabolic activity is tightly linked with glycolysis, the process of breaking down glucose for energy. So whether talking about energy behind focus and ADHD, a delicate balance of neurotransmitters and dopaminergic pathways, or the tiny molecules orchestrating brain activity, one thing's clear: our brain's chemistry is a beautiful, intricate dance. Thanks for joining me on the microscopic adventure. Until next time.